Mhm. Okay, I'm Wolf McNally, lead researcher for Blockchain Commons, and I'm going to give a quick demo of doing a request and response for a key derivation from a seed. So I have two screens visible right now. One of them is the iPhone simulator, and the other is my actual iPhone that's hooked up to my Mac. And so they both have the same seed in them, but that's not required for the actual uh, um, use of what I'm going to show you, but it's the easiest way to demo this. So I'm going to start seed tool here, and you see it's got 4 example seeds, including this top one we call khaki, which is just an example seed. There's no value associated with any of these seeds that you're seeing here. These are all example seeds. Um, and we are going to assume that we're using a different tool that doesn't have the seed for now, but we're going to go into the seed here, and we're going to ask for we're going to look at the cosigner public key of the seed. This is um, a BIP32 derivation along this path that yields a master key with this fingerprint. Um, and this is the actual HD key, the public HD key. So we're going to, I have a feature turned on called show developer functions that's turned on right now. So anything you see with this bug by it doesn't appear if you don't have these turned on. So when I show the cosigner public key, you'll see that there's 3 buttons with bugs on them here. And so one of them is show request for this derivation. So when I do that, it's actually assuming that this is some kind of device that wants a derivation of this sort. It doesn't say what key it is. It doesn't say what fingerprint it is, but it wants a derivation of the cosigner public key from some seed. And it says, we have our UI paradigm is of the form of a chat. So in this case, it's a ask you a question. I would like a Bitcoin public key of this derivation, please. And it's showing an animated QR code. We've talked about this in other of our meetings and videos. This is there are multi-part UR format that can basically use streaming fountain codes of any length. So you're not limited to the size of QR code or the resolution of your camera or screen. And so I'm actually going to now pull up Seed Tool on my actual phone. So on the left, well, I don't know if it's on the left or the right from your perspective,
On our
but
left.
it's on your left. Okay, so um, so as you can see, I've got other seeds on here on my phone here. These are again are all example seeds, but I'm going to tap the QR code button in the lower left-hand corner, which will put in the camera mode, and you can see my console now. And I'm going to focus on the actual QR code that's animating right now. And you'll see you'll probably read it very quickly, but okay. So what you see now on the left there is it's received a request. And so the remote device has asked for a public key for mainnet, master key of the same derivation path. And now we have to respond. And that's why there's 3 dots in the answer bubble here. And it basically says, another device is requesting a public key from this device with this derivation. The sender of this request attached a note. Now, this is something, again, because this is a dummy a dummy derivation request. It's basically attached a random note just to show you that we can attach metadata of any kind to this. So it's just lorem ipsum mock Latin. But basically says you must decide whether to trust what it says. Seed tool cannot verify its accuracy. So this is intended to be human readable, that is conveyed from the requester to the responder. And then it's asking you. Hmm?
Go ahead.
Yeah.
Explain the bottom.
Yeah, so it's basically asking you, it's basically saying, here's the derivation key, and it also identifies as a native SegWit multi-sig cosigner. So it knows this kind of key that it's asking. So because this isn't tied to any particular seed, you're asked to select a seed. So I have to do that. I can't do that with my mouse. I have to do that with my finger. Okay, there we go. And so I can use any of these seeds to provide the cosigner for this. And so I'm going to use the one called Dark Purple Aqua Love here. And when I select that, then here's the question, and then here's basically the derivation that's been done from that key, and then it basically says setting this public key will allow the other device to verify but not sign transactions with it. This key is derivable. Additional keys can be derived from it. It tells you the derivation path again, and then it tells you the seed that's going to do, and then it asks you if you want to approve this. So when you say approve, then you get another animating QR code, which is basically the answer to this, which is the actual key that's been derived. Now, I'm not going to read this again because actually Seed Tool doesn't read keys. It only reads seeds. So, but any other wallet or anything like that that wanted this key at this point, and you can, share this in various other ways. You can write it to an NFC tag. So if I say share as your envelope, then you can copy it to the clipboard, or save it to any of your file systems or send it directly to somebody. You can, if you say write to NFC tag, then it'll ask you to put an NFC tag here close to it so it can write to it. So there's lots of different ways that this response can go back and forth. And of course, as you see on the simulator as well, you could have done the same thing with that. There's a share as your envelope, write NFC tag. So,
This is
so
particularly
yeah.
relevant to Sato chip, like you were just talking about putting in, supporting an NREF. You could put this QR code that's on the right as a UR. So show them the UR form of it, Wolf.
Yeah, so okay, so if I say share as envelope and copy to clipboard, the easiest way to do this is probably, let's see what's the easiest way to do this, because
Put it in the chat. It's a public key.
yeah, well, no, it is. Well, actually, do you want the request? It's a UR either way, but I mean, actually, here, let me do it this way. I'm going to open a terminal window. I'm going to share that window. Let's just share that window now. All right, so you should be seeing my terminal now. So the when I copy that UR to the clipboard, if I just say envelope, this is our envelope command line tool, and then I just paste it, you notice that this is the actual data. It's a UR, which is uniform resource, which is an encapsulated binary data object of type envelope, which is Gordian envelope. And then these are the byte words of it, which includes a CRC32 checksum at the end. So the last 8 letters of this are the checksums. You can always look at the last 8 letters and see what they are. And if I just have it parse this, then you see that it actually shows the contents of this in envelope notation. This is a request with an identifier. This is actually a 32-bit long identifier. This is the first 8 digits. It has a body, which is a function, get key. It has some parameters to it. It wants the derivation path, which is a key path, which is a CBOR map. Everything is based on CBOR. You see here at a lower level. So this is just this is CBOR tag key path. This is the CBOR map that contains the derivation path. That says it doesn't want a private key; it wants a public key. And then here's the actual note. So everything is actually very easily parsable. You don't even technically need an envelope stack to do this. You can parse the CBOR directly if you know what you're going to get. So even on size limited devices, you can actually parse the CBOR directly using a very tiny CBOR decoder and still understand this. So yeah, that's the actual request. Now, if I copy the actual response, so I'm going to go back to my phone, and I'm going to copy the clipboard, the response, and I'm going to do the same thing here now in the terminal. Here's the actual response, and as you can see, it's got different last 8 letters. That's all you need to see. Is any of the last 8 letters different? It's a different envelope. I'm going to parse this, and you can see it's the response, and it's the same response to the request. So here's the request. Here's the response. It's a result. The actual result is here. This is the actual key, the 33-byte public key. And then there's other attributes here which say it is a public BIP32 key. It's a public key. Here's the asset it's set for. Here's the chain code. Here's the name that was derived. Here's the parent key path, and here's the parent fingerprint. So everything you'd expect in a BIP32 derivation is here. And so that would be that's the actual response. So that's an example of using envelopes and URs to actually perform a remote function call. Essentially, this is the actual function call identifier, and then the actual response to that same request.
So to go back, show this the iPhones again, and show the other requests, and then let's just talk a little bit more about other kinds of requests.
Sure. Let's see. Okay, so you should be back to seeing the iPhones here. So So yeah, so many of the places in this, if you ask, for example, it says show example request for the seed. So in this case, you're actually requesting the seed itself with this fingerprint. And then again, this can also respond to that request. And that's a request that that envelope can respond to. And notice that in Gordian Seed Tool, everything that's not sensitive, that's public keys and so on, are colored green, and anything that is sensitive is coded yellow and actually needs additional biometric authentication or two-factor authentication to do it. So right now the simulator doesn't require that, but on my phone it would. But for example, if I can say show example response for the seed. So here's the actual example request. If I actually want to generate an example response to a request, I can do that. Again, it looks the same, except, it's coded yellow. And then if I go to, let's see, where's the other? Oh, and also you can see the envelope that will be generated for this actual seed. So, and this is again with the developer tools turned on. If you export the seed as an envelope, this is the same envelope notation you saw before, but for the seed itself. And then let's see, I'm trying to figure out where else I have the developer. Drive key.
Oh, you have it under the, yeah.
Yeah, so
There.
so this is actual, right. So this is actually for the cosigner uh uh private key. So again, these are all yellow, but the requests for these are green. And so if I again show request for the key, so in this case, it's asking a request for the actual derivation of this specific key along this path, as opposed to just any general key. So same basic idea there. Show request for this derivation. Notice it's not specifying a master fingerprint in this case. It's just specifying the actual derivation path. So where there are at least 4 transactions that Seed Tool knows how to respond to: a request for a seed, request for a derivation, request for of a key, request to sign a PSBT, and my mind's slipping what the 4th one is at the moment. But
Yeah.
but yeah, so it's just, but it'll actually generate requests that other things can respond to, but Seed Tool isn't designed to respond to those things itself.
So again, the purpose of Seed Tool, which by the way is free today and tomorrow, is not really as an end user tool. I mean, we've tried to do as much as possible, best practices and such, but more of a demonstration of UX, of code, etc. So you'll notice that all of those things had a little option for NFC. So like what I do is I have some cheap NREF only cards, non-smart cards, and I have all these requests on it, so I can just tap Seed Tool with these requests and make sure that it gives all the different choices that are there. We'd like it to do more. So right now, Seed Tool does not support requests for sharding and requests for recovery. Although we do allow you to put secret shares into NREFs. Actually, you want to show them that real quick, Wolf? You don't
Yeah,
have to
so
show them the SSKR to paper.
sure. Yeah, so here's a seed, and if I want to back this seed up, I authenticate, and then I say backup, and we can back up as a single Gordian envelope, which you saw the actual below at the bottom here is the actual envelope contents, or you can say backup as SSKR multiple share. SSKR is um, uh, sharded secret key reconstruction, which is based on Shamir secret sharing. And again, everything I'm showing you, by the way, is open source. So all the libraries we use, the app itself, even though obviously most people could just download it from the App Store, and it's actually free right now. The app itself is open source. You can go to GitHub and compile it for yourself and see all the code we're running, the whole stack. So everything we do is very transparent. So there's no magic here. So if I say backup as SSKR multi-share, it asks me if I want to back it up in the Gordian envelope format, which is suggested because you get metadata like name, notes, and so on. Or you can just back up as a legacy UR, which is just the seed itself. But then I have to decide what kind of sharding I want to do. And a very common one is 3 of 5. So and you can actually have groups. So I can, for example, 2 or 3 shares of 2 or 3 groups. So you can actually create 9 shares distributed among 3 groups, and then you have to get a minimum of 4 shares from any of the 2 groups to actually reconstruct it. So it's up to you to decide based on your risk surface and so on how to do your social key recovery. But let's just use 3 to 5 for now. So I tap next, and at this point the actual shares have been generated. In fact, that's why it says generated February 7th here. It says for security, SSKR generation uses random numbers. Because of this, if you leave the screen and then return, the shares shown will be different from and not compatible with the shares available below. Shares created at different times cannot be used together. Be sure to copy the shares to a safe place. So you can print them all, which is what we're going to do in a moment, or you can export them individually, and I'll show you that too. If I say print all shares, then you basically get a couple options. If you want a summary page at the top, you can. And you can also include the seed notes. So if there are seed notes, notice that it says actually has them here. If I turn that off, then they go away. But notice also that there's these 4, and I'll show you the printout closer in a moment here. This is the summary page. And if I go to the other pages here, you see they all look pretty similar. They have a QR code and they have an envelope, but you cannot derive the seed from this envelope directly. You have to have at least 3 of the 5 to actually generate them. So I'm going to go ahead and say print here. And this is the actual print dialog here. Let me actually make sure the print simulator is running here. There we go. So I'm going to say save original simulator. And then I'll say print. Now I'm going to share my the actual window that comes up here in a moment. So what you're seeing now is the actual PDF that was printed through the print simulator. And this is the cover page. And again, it says the following verification words may be used to establish that printed shares are part of this SSKR share collection. Check them against the last 4 byte words of each share. Only shares that were created at the same time can be used together. So we're kind of repeating that warning. And it says 3 of 5 shares in this group must be met. So the owner of the shares could keep this without actually keeping any of the shares. They could give away all the shares and just keep this. And so this is the actual last 4 byte words, and I'll show you how that works in a moment. This is the note that was with it, and then here's one of the shares. This is the actual UR envelope that's in that. This is the actual QR code for that, and notice it says hang lava pool iris. Okay, so how do you know this matches that? Byte words, there's 256 byte words. They're all 4-letter English words. And it's basically been designed so that they're all very distinct from each other, including the first 2 letters being distinct, the last 2 letters being distinct, and the first and last letters being distinct. So iris can be abbreviated IS. And notice that the last 2 letters of this are IS. The second word, the word before that is pool, PL. And you see before that, PL. And similar LA for lava and HG for hang. So hang, lava, pool, iris. And so you can see this is the actual same envelope as mentioned here. So and similarly, the rest of everything here is the actual share. If I go back to my phone here. So if I say export shares individually, then you see here's the first share, hang lava pool iris. And right now you can export a number of different ways. As envelope, as you were seeing, as byte words, as a QR code, to an NFC tag, and notice it changes to NFC tag, or to print a share individually, which you just saw a page that's printed from that. So you can decide how to deal with each share individually. So for example, if I say envelope, and if I show that, you actually see the actual text of the envelope, and there's the last 2 letters, IS. So you can already see that that's the same envelope. Byte words, this is a lot of byte words. You would want to enter these manually. For very short seeds, you might, but not generally this way. The QR code, this is again the animating QR code that contains the envelope, because again, once you have the animating QR codes, you don't care about whether it's a big piece of data or a small piece of data. It's very quick to read. Again, write to an NFC tag or print it. So I'm going to go back to envelope here. I'm actually going to, I'm gonna actually, many of the things that Seed Tool displays are just, you can actually tap and hold on them to copy them. So I'm just gonna tap and hold on this. Copy, it says, what do you want to do? I'm going to copy this clipboard. And then I'm going to go back and share my terminal again. Where's my terminal? we go. Okay, and then I'm going to go envelope and paste this. And notice again, the last two letters, PLI, or 4 letters, PLIS, so you can say this is the same envelope. And then I'm going to parse this. And this is very simple. It's an encrypted object of some kind. And then it's got one assertion on it. This is an SSKR share. And then this is the actual SSKR shared data. So this is the actual payload that's been symmetrically encrypted by an ephemeral key. And then it's the actual ephemeral key that's been sharded. And this is and the shard is contained in this. And that's all you get if you're basically a recipient of one of these shards. You get an opaque encrypted payload and the share attached to it. And so that's different for each of these shares you saw that I could export, the 5 shares of this 3-to-5 split. So
So if
go
I
ahead.
want to quickly connect a couple of dots here. So let's say this was placed onto an NREF of a card, or sent via an API, via API through the Java card API. The two basic functions you'd need to do to be able to the first thing would be you would have to get at least 3 of these onto your card. There is a Java card library for SSKR, which would allow you then to decrypt this into to get the ephemeral symmetric key for this package. And then there is also a Cha-Cha Poly. What's the full name, Wolf?
Well, we're using the
Cha-Cha Poly
yeah,
something
sorry,
weird.
my mind's blank. It's IETF Cha-Cha Poly, and then if I'll find it.
And we've also shown that there are libraries for Cha-Cha Poly for Java card that can decrypt this. It's not super fast, but given that it's not something you do very often, it's like a 1 second, 1.5 second operation with a Java card library. So that basically means that a device of Java card family could both receive shards in order to create a key for the device, or alternatively be able to back up the seed that it has on the card, split it into a 3 of 5, and then be able to share those shares out to other parties.
Right.
So
It's Cha-Cha Poly, Cha-Cha 20 Poly 1305. That's the name of the ITF standard.
do you want to show him I don't know if he's show him the recovery with your other phone?
Yeah, I was going to do that actually. That's why I actually pulled up this share now.
Yeah,
So, so I'm going to pop out of this, and I'm actually going to delete this key, this seed from my phone. So I'm actually going to delete it. Okay, it's gone. Now I'm going to actually go into the camera mode here again. And as you can see, I'm showing the same part of my screen here that we were just looking at here. So that's the cover page. So as I scroll down it, I'm going to focus on that QR code. Notice it says recover from SSKR. It's got one group and there's 3 shares required. So it knows that just by scanning that. So so now I'm going to say say skip the next one. So I'm going to skip past the next one, so it can't read that. And then we go back to the next one here, and it's got it. And then I'm going to skip past the next one here, and then read the third. And there it is. It's got everything that it had before, including the notes and an attached output descriptor. I'm going to save that, and there it's back in my library. So that's an example of SSKR key reconstruction.
So
Seed
again,
reconstruction, let's say, in this case.
we also can do this with PSBTs. So if a device say Sparrow or some other coordinator wants something signed, it can use these same request capabilities. I don't know, do you have something prepared for that, Wolf?
For signing PSBTs?
Yeah.
I can show how a signature request looks. Essentially,
Sure.
I can show the actual interface for that. So let me take a moment to pull that up.
So some of the things that we don't have because we need to work more closely with, actually, let me back up a step. What is the motivation for all of this? So Shannon and I wrote in 2018 and published in, a new version in 2019, something called the Smart Custody book. And it was all about best practices for storing your Bitcoin, and it really focused on single sig backup best practices. And it was well received by a lot of security experts, but it's still, it takes you 45 minutes or so to do the process. And what we found was people didn't do the process. And it was focused on single sig, which of course has its weaknesses. So we published in 2021, I don't remember exactly when, a scenario that leveraged using Sparrow as the coordinator without any keys, and then used foundation devices as one of the keys, an offline key in the form of one of those backups that you just saw, and Seed Tool as the tool that created those backups. And I think also a little memory card that Foundation Devices supports, which again is very secure, but it was in many ways too complicated still. As much as we tried to make it high security, the steps you go through were kind of long, and people who even had lots and lots of money on Bitcoin were going, oh no, this has to be easier, or I'm not going to back up my Bitcoin, which I think is silly, but that's the reality of things. Um, so we basically did try to understand the user experience and what causes all of this type of stuff. And that's where we basically came up with this sort of request response paradigm, which is represented by the Gordian transport protocol, which is what we've been using for these types of things. And it allows for a lot of these kinds of interactions to be automated. What we don't have is what I would call a partial descriptor request. We have PSBTs, obviously, which is what Wolf's going to show you in a minute. But there's a similar problem of, okay, I've got a partial descriptor. I want to verify that the first public key that's in here is somebody's real public key, but the other two are empty. I need to fill one of those two. And this can be, done by hand with the key thing that you just saw. But we'd like to have something that was maybe a little bit higher level that, just basically did all of this and did it right. Similarly, there's some tofu requests that would be useful for the seed recovery servers, social key recovery, and NFC cards that we haven't fully articulated what the flow would look like. And that's where we need people like you to work with us on, what would be the useful things that your card could request or your card could respond to a request that would be useful. So we'll go to PSBTs now.
Yeah, so I have here, this is a folder in our archive here called testing. It's got some PSBT signing requests in it that can be signed by our sample seeds here. The sample seeds are called Alice and Bob. And the PSBT signing request limit is the 202, which requires signatures by Alice and Bob. And there's several different formats of that here. There's the bare PSBT, which is basically just the actual PSBT in I actually scan it using a third-party app here. So as you can see, this is a crypto PSBT, which is, again, it's a UR, but it's the raw PSBT. There's no other that's been encoded as a CBOR string. There's no additional metadata that the PSBTs don't support in it. Whereas the other one here, the PSBT signing request, is actually the full signing request. And Seed Tool can use either of those. So we're going to use the signing request itself. So I'm going to go back to Seed Tool here. And I'm going to, and as you can see, I've got Alice and Bob here. There's Alice and Bob. And I'm going to go into the camera mode here. I'm just going to scan the signing request. And again, here's the same kind of interface you saw before, where in this case, the remote device or the remote QR code essentially. Sorry, what?
Can you zoom that a little bit?
Zoom it.
Just
I can, I'm trying to figure out how to make it bigger for you. Is that better?
that's better. Yeah.
Yeah.
Okay. Um, so in this case, the QR code contains a signature request, and we're deciding what to do about it. And so it says another device is requesting signing on the inputs of the transaction below. If you approve, this device will sign one input on the transaction using keys derived from two seeds on the device. Once signed, this transaction will be fully signed and ready to send to the network. So if it couldn't sign all the outputs and has to leave some of them unsigned, it would tell you that at this point. And so it gives you a summary of the transaction, in, sent, fee, and change. You can display addresses for mainnet or testnet if you prefer, but then the input that's being signed, it's telling you which seeds it's going to sign it with and which derivation path it's going to use. And then and then the outputs. And then again, it's asking you if you want to approve. And if you approve, this is a signing response that you can actually share as a raw PSPT, a binary, which you could, write to a card. You could write to an NFC tag, or you can display it as a QR code. In this case, it's a UR envelope. And again, this is, this presumes another device is going to read this and then either send it on to other signers or consolidate it with other signed PSPTs.
Yeah. And right now, Sparrow will read the QR of I think both now, right? Doesn't he support
I
the
actually don't
latest?
know. I don't know if he's supporting the very latest, but I know obviously he supports the raw PSPTs, but I don't know if he supports envelope or not yet.
Anyhow, you get the what we're trying to do here. Again, we're not a wallet provider. We are doing all of this to support you. This is all open source. Everything you saw, including the examples, are on GitHub. You could use our app to test and do more things with Saddle Chip. You could do PRs to help us do specific things with your technology, and you could use our code in your own apps if you have an iPhone app, or we're working on also a Rust stack for all of this. So you could also do a desktop
A
app
good
or
chunk of
something.
what you're seeing right now is available in Rust as well as Rust native code. By the way, Christopher, I don't know if you want to take this opportunity, but I can also show a little bit about creating seeds, driving keys while we're at it. So
Some best practices we're trying to demonstrate to support wallet developers on good UX.
yeah, so creating seeds
Can
obviously
you
is.
go on the right? Can you get? We don't need the. We don't need
Oh
the.
yes, yes, yes. Let me turn off. Yeah, exactly. So let me just go back to my iPhone here. Oops, I turned off the wrong one.
Yep.
Actually, I'm gonna go back to the simulator because that's actually probably better for our purposes. Okay,
Okay.
so
Good.
I can actually click on the screen. You can see my cursor. All right, so let's assume we want to create a new seed. To do that, you tap the plus button, and you have quite a variety of options to add a seed. And you can either create a new seed or you can import seeds from various kinds of formats, including bit39, SSKR shares, raw byte words, just hex bytes, or an envelope or UR seed. So, if I just want to do a quick create, and this is basically using entropy provided by the cryptographic strength random number generator in the OS. I can do that, in which case I'm done. I can click save. I can, if I want to, I can still edit the various things like the name and output and so on. But you see, that's the actual envelope that would be created by this. It's 16 bytes and 3 assertions on it, including what it is, the date it was created, and its name. And then, but the actual subject of the envelope is the 16-byte seed itself. So let's say I don't want to do that. Let's say I want to create my own seed from scratch using my own entropy. And you can do that using coin flips, die rolls, or playing cards. And so, for example, if I wanted to use playing cards, this assumes that for full entropy, it assumes you're shuffling every time and drawing a card. And so, for example, if I draw like ace of diamonds, you can see that's 5.7 bits of entropy, very weak. So you want to get up to at least 120 bits of entropy. So I can, 9 of clubs, 10 9 of spades, that is 9 of hearts or 10 of hearts, or you can have it roll random cards if you want. So you can do that, or you can roll up to as much as you need to actually get the entropy you need if you just want to demo it. So at this point, I have a very strong entropy. I have 131.1 bits of entropy. You can also copy or paste these things. You can share, copy or paste the actual. So if you want to generate these somehow, like in a text editor, there's a text format for these.
And you can confirm it with some other tool that it generates the same.
Exactly. Yeah, because the exact same entry should always generate the exact same seed, which will always generate the exact same keys and things like that. So you can use die rolls, and you can use coin flips. So it's up to you to decide, what you want to actually do to actually get the entropy for your key. And the same entry will always generate the same key. You can also basically paste in, for example, byte words or SSKR. So let me demonstrate this by saying, actually, BIP39 is what I want to demonstrate because BIP39 is very well known. Let's take one of my keys here. I'm going to authenticate, and I'm going to share the key as BIP39 words. I'm going to copy this to the clipboard. And I'm actually going to go ahead and I'm going to paste that into my terminal. You wouldn't be able to see that, but it's got 12 words here. And then I'm going to go to I'm going to go back. I'm going to say add. I'm going to say add BIP39 mnemonic. And now I've got the words here on my screen. You don't need to see them, but I'm going to start typing the first word, ADMI. Notice at this point, it's saying that this is enough to determine that it's got a word here. Even though I have ADMI, it says admit is the word, but that I need at least 12 words. So I'm going to press space and type GL. And notice that it says there's 35 possible words that have these letters in them. So it's basically, it's ambiguous still. So I'm going to type the next two letters, IM. It says, oh, that's the word glimpse. And then I'm going to type, say, the next word is spatial. So I'm going to type this SPTL. And notice that it still says that's ambiguous. So I'm going to say SPATL. Notice it's actually figured out that this is the only possible word given this letter sequences. So you could type the first four letters. The first four letters of a BIP39 word are unambiguous. But if for some reason words are illegible or whatever, but you can, it'll tell you basically if any of these. So I'm just type, let's see. So that's let's see, it's the next word is combine. Combine, dignity, purchase, such, switch. Notice they got that after the four letters. I'm going to type the last letters of this one. Planet. No, so there's two possible ones there. PLN, planet, bargain, lab, solar. And there you can see it's got the key now. No, it's got the seed now. And you notice that there's no metadata and like that. That's not part of BIP39. It's just 12 words, but they're easy to back up. So if I say done, then it's actually going to import that. Let me just show you the other way of doing this, which is byte words, which I think is actually even easier. So if I go to, again, that same one, and so I authenticate, share as byte words, copy to clipboard. So I'm going to paste that into my terminal now. And I'm going to say, add a new seed from byte words. Same basic idea of the interface here. So I can type the actual byte word, APEX. Remember, they're 4-letter English words. It says you need at least 20 byte words. Currently, you've got one. But the nice thing is I can type like the first and last letters of this. PS is plus, IO is into, FW, CM, WF, BY, HG, HH, KO, CK. Oops. Notice if I type a sequence that's not valid, it basically says that one it cannot be a valid byte word. CK, BY, ON, BO, GO.
Some other cool things about byte words are not only are they unique in first last character and various aspects of that, they've been very carefully chosen to be easily memorizable, to have a large hamming size, I guess, so that they're very difficult to type the wrong word.
It's also very difficult, even if with an accent, to mispronounce one of these words. They all have very different pronunciations in the IPA dictionary, and they all have a certain distance, a certain number of letter distance between them in terms of number of positions that need to be changed. And like I said, they're all unique in their first 3 letters, the last 3 letters, and the first and last letter are all unique.
And we've also avoided, there's a list of words that are the most commonly mispronounced by foreigners that
Mhm.
we've also eliminated. So it's a really interesting list. As you can see, we use it in a lot of our different things. But why didn't we just do BIP39 words? Well, part of the challenge was that we had multiple needs, and we needed something that could be compressed tightly by QRs.
Right.
And a lot of the other alternatives that are out there, um, will have a single character in them. So like base 64, will be basically doubled in size in a QR code because of one character in base 64 that is not part of the QR code set for
Right. So
compress.
base 64, right. So base 64 is a great way of compressing or of armoring binary in text, but it's actually less efficient in a QR code because it requires that QR codes use what's called their binary encoding mode, where every character you type actually uses 8 bits of data in the QR code. So there's another encoding mode in QR codes called the alphanumeric encoding, which essentially is just the uppercase letters and a few symbols, including colon and slash and hyphen. And so URs only ever use those symbols. And so if you create a UR, which includes these byte words, um, and can only include letters from that alphanumeric subset, and then you transfer them to capital letters and put them in a QR code, you actually get a less dense QR code than the same data base 64 encoded in the QR code. So it's designed to both be handleable by humans as a URI, so you can copy and paste URs. It's designed to be very efficient in QR codes, and it's designed to be for at least short sequences memorizable or verbally transmissible and very easily, for example, engravable into metal or things like that with just a few words. So it's balancing a number of different needs of the law and digital privacy community at the same time. And I think we've done a pretty good job of it. And of course, it's not going to be perfect for every need, but it does, it solves, I think, a lot of the needs that were in existence when we created it. And I think I'm very proud of the work we've done on it.
Quick question. Would it make sense to make it compatible with BIP39? I know the two are not probably, but you could do like BIP39 first and then get like a 256 or 128
Well, we support
bits.
fully now. So, we support, you can either export it in any of the legacy formats, the BIP39 mnemonic, et cetera, but you can also export in a variety of formats, including just plain old hex, the raw
Yep.
value without a CRC.
And the nice thing about Gordian Envelope, for example, is you get all the metadata. Whereas with byte words or BIP39 words or hex, all you get is the pure seed. So so there's different reasons to use these different things. Byte words is part of the UR specification, which Gordian Envelope uses. So everything we do is in a stack, but we also support very important legacy protocols like BIP39, which you just saw me kind of back up and restore a seed using that. But that still doesn't give you all the metadata of the seed that our tool stores, which would include, its name, its creation date, its note, its output descriptor, and you can see those are all represented here in the actual envelope.
And some of what we've
And
go ahead. Go ahead.
also for seed generation, am I correct in understanding that you would need to first generate it with BIP39 because that's like a one-way process where you do a hash of the words and then you can encode that in whatever other like better standards that you prefer?
Well, internally, basically, because we want to be compatible with all the other BIP39 based tools out there. When you generate entropy, there's other, like for example, websites that let you generate entropy in BIP39. We use their same method, which basically actually internally does transfer through BIP39, but you don't see that when it does this. But we're compatible with those methods. So for example, if I use die rolls here, it will give me the same, and use the same 6 die rolls, it'll give me the same seed here as it will on a website that actually lets you generate a seed using die rolls.
Yeah.
Because
Also, BIP39 is a little weird in the sense that the very last word only has like a couple of bits of the randomness in it. The rest of it is sort of like a checksum. there are wallets out there that that especially ones where you can do all the operations completely by hand for creating the seed but creating that last value, once you've got like 11 words, you just press one button and it'll make the 12th word for you, because that is kind of a hash checksum.
It's a check word, yeah.
That being said, the problem with that particular technique, maybe we'll add it to Seed Tool if there's a request. But part of the reason why we don't do it is that, in fact, there are multiple valid values. And there are a couple a bit different. So, you can basically, by hand with just a piece of paper, create the 12 words and be able to verify that the 11 words are accurate. It's just the construction of the last word that really needs a computer. And but you could create the first 11 words, confirm it with Seed Tool and other different types of tools out there, but you could technically create, I think, 256. I don't remember how many bits. There are some random bits encoded in it. But it's not, there's no deterministic way if you have the 11 to determine what the 12th word is. But you don't really ever need to, if you've got if you've got 12 words or 24 words or whatever, you don't need to hash the you don't need to hash the BIP39 words, because there is an inbuilt checksum in there.
So the only other, go ahead.
The point I was trying to bring across is that so many people are so sort of tied to this, like it's such an industry standard, if you like, that even if you find a better way, and there is a better way with all the metadata and stuff, it would be very nice if it was compatible in a way where they can take their existing 12-word seed and then encode it in this other.
Yeah. Well, that's exactly what we support. They can anybody can take their existing. Right. You can take BIP39 seed from anywhere, put it in here, and get the exact same seed out. So
you can just paste it in it.
Right. So the only other thing major aspect of the app I haven't shown off is the key derivation. Would you like me to show that now, Christopher?
Sure.
All right. So whenever you have, first of all, I want to point out that Seed Tool supports 3 major cryptocurrencies directly, and that's Bitcoin, Ethereum, and now Tezos in the latest version 1.6, which is now in the App Store for free for a few days. It will also sync your seeds to iCloud if you wish, or you can keep it entirely off the internet and basically have a cold device if you want, and just use air gapped to go back and forth. But I'm going to leave that set for Bitcoin right now. I'm going to go to just into one of the keys here and say authenticate. I'm going to say derive key. Actually, I'm going to turn off the show developer functions because they just add noise if you're not going to use them. So that's how it would normally look without the developer stuff on. I'm going to say derive key. And then you've seen the cosigner private key, which is a specific path that we use frequently, but there's other key derivations. And so this pulls up this workflow here where you see the seed flowing into parameters, flowing into the private HD key, flowing into a secondary derivation, public HD key, and finally the address. So these things are all derivable from this seed directly. And there's basically 3 major paths: Bitcoin, Ethereum, and Tezos. So if I switch just to Ethereum, it still asks me if I want mainnet or testnet. But for example, Tezos doesn't support mainnet and testnet. It's just all the same keys. So that goes away here. It shows you the Tezos derivation path. Let's just stick with Bitcoin for right now. So you can either go with the master key, or you can go with the cosigner. Notice how this changes because this is the cosigner key. Or you can go with SegWit, or you can enter any custom derivation path you wish down here, and it will use that derivation path. So let's just go with the master key for now. So here's the master key. If you choose master key, you can have a secondary derivation, which is the public key and the address associated with that. Or you can ask for an output descriptor, in which case you can decide on an account number, and then you can decide which derivation path you want for your output descriptor. So if I choose, say, just native SegWit single key, then here's the output descriptor derived from that. Again, I can just click and hold on this and copy to the clipboard, or I can share it in various ways, including writing it to an NFC tag, or sharing it as your output descriptor or an envelope. Or just sharing it as plain text, which of course is even easier. Just click and hold on it here to share it as plain text. So
This is the latest output descriptor, so it includes the little checksum value
right.
the after the parentheses.
Yep. And so if I, for example, now if I say, and what you saw in the settings is the default asset. So for example, if I go back here, if I change this, maybe I only work in Ethereum. So I'm going to go to Ethereum here. And that basically means that when you just say derive other keys, that it's automatically be selected here, but you can always reselect any of the cryptocurrencies here, but Ethereum will now be selected by default. So you see here, I can either the master key or the Ethereum. Here's the actual private key, which is and the address, which is basically this is the standard way of representing visual hashes for Ethereum. It's called block keys, and so we support that as well. So you can immediately tell if you paste this private key or use a public key address from this in another wallet, you'll see the exact same block keys there as well. So it's compatible across wallets with that. For Tezos, again, there's a derivation path for Tezos. And then the private key and the address, which is a TZ1 address, derived using the ED2525519 curve, and that's compatible with Tezos wallet. So if you actually paste this into a Tezos wallet, then you'll actually have that wallet. And if you paste the address, then you'll have the address. So, and what
And if
the content
you know of any other derivation, like there is a technique to generate a key for PGP from a seed, that's just a derivation, and you can do any arbitrary derivation with this tool that you like.
right? Yeah,
Um,
using BIP32 derivations at this time. Yeah. So,
and of
but
course,
that,
all,
go
all
ahead.
of these, we have the developer functions that show you how to request these things. So you can
Mhm.
request something weird, like you need such and such. And then we'll, as you saw from the previous dialogue, we'll tell you, well, we don't know what this is that somebody's requesting. It's like,
Yep.
it's not on our list. You can do it. You can say yes, but it's not a Bitcoin one. It's not anything we identify, and then within, say, Bitcoin, it's not a SegWit or a Taproot or any of the standard things. It's something weird. It'll warn you. And so we do a lot of things to try to be, careful there. Again, to try to represent some best practices that we hope more wallet developers will use.
One other point I
Oh,
want to make is when you have used Bitcoin, in addition to requesting, if you're deriving from the master key, you can get the public key, or you can get output descriptors I pointed out, or you can get an account descriptor, which is a bundle of output descriptors that Sparrow Wallet can read directly and things like that. So they can decide which output descriptor they want to use on the wallet side, because you're exporting a whole bundle of output descriptors.
so anyhow, that's the current version of Seed Tool, and sort of I think you see why we have the tool available to help developers test all of this stuff. I mean, it is useful in and of itself. Do you have Wolf? Can you show like the single seed printout?
Oh yeah, sure. Yep. One sec.
So, one of the things that, we're saying that really nobody is doing well right now is, if you've got any kind of multi-sig, you have to back up the descriptor. Well, there's not a
Actually,
descriptor on.
yeah, hang on. I'll get one here that does.
I
Okay, so
think it's because you're in an area.
this one has long notes and a descriptor.
I think
And
you
I'm
have to
going
switch to Bitcoin. I think you're still in
uh
it.
you're yeah, you're right. Hang on. All right, so I'm going to authenticate, backup, Gordian envelope, and print. Now I'm actually going to print this and then share my actual printout here. Okay. Christopher, I'm actually being called away on a family thing for a minute. Would you want to
Sure,
explain this?
I'll walk him through this.
Okay, I'll be right back.
So, the obviously the QR at the top is what will allow you to restore it. And it has the name, the fingerprint, the master key fingerprint, It has the raw hex. It has the creation date, which is really useful for a lot of Lightning apps. They don't need to check any transactions before that date. Actually, a couple of different protocols that's important. The byte words version of it, the BIP39 words, the actual envelope in text formats. This is exactly what's in the QR. The output descriptor, which is especially useful if you just want to create a watch-only wallet for this. Instead of rather than using the key on the top right, you can use the output descriptor to very quickly create a watch-only wallet for it. And then there are the notes, which you can put arbitrary information in. This also is a really good demo of another feature of Envelope. Because of the constrained amount of space on this page, we basically can't fit that all onto a printout because we can't do animations on a printout. So what is the right thing to do? So what happens in this particular case is that you'll see this warning thing, some metadata was elided to fit into the QR code. What it does is it's actually going to hash the notes. And it creates an elided field in this shorter QR that basically says, oh, these notes are now missing. This is really useful for a variety of cases. You may want to deliberately elide something. Maybe you don't want to put all of your transaction data and other different types of things into the envelope. Maybe you do. So it's also a good developer reference that, hey, you should be prepared when you're restoring that there may be data elided in the restoration. And you can identify, oh, there are notes, I don't have them. This is also particularly good with SSKR in constrained situations. So for instance, I could put, say a 3 of 5, I could put one of the 3 of 5 not elided at all on iCloud. Okay. And I can do that safely, easily, and those can be fairly large objects. It can have everything. But then I also want to put one of the shares, the fifth share of a 3 of 5. I want to put that on a piece of paper like this. Well, I can't put all that metadata there, but the hashes of the metadata will be there, such that when I restore all the different shards, even though this is a small shard, it will be able to verify that the large shard that I recovered from iCloud is valid and give me all of my data back once I have a quorum of shares. So that's really a powerful capability. Each shard has the ability, each share more properly, that shard is the verb, share is the noun. Each share can have slightly different information in it, which can all come together and be verified when a restore happens. And I think this is also important in the NFC side of things because there are real limits on what you can put on NFC cards and things of that nature. So this is a useful demo of the elision capability. Wolf, can you quickly grab this elided envelope and show it in the terminal?
Yeah. So let me let's see, easiest way to do that. Okay, so I'm going to also share. Oh, excuse me. I'm going to share my phone as well. And I'm going to actually, okay, so I'm going to go to the QR Reader app, third-party app that I use for this. I'm going to grab the QR code you just saw there, and there you see the UR capitalized, so you can use the efficient QR code encoding method. I'm going to copy that to my clipboard, and then now I'm going to share my terminal again, and that was the previous seed you saw. Clear my screen here and type envelope, and then paste that UR in, and you see that again. Here's the actual seed. It's the subject of the envelope. It is a seed. The date has name, but the note says elided, And what that basically means is that the SHA-256 hash is still left as a marker here. And so only the notes that are actually in that original thing can replace this without changing the whole hash tree of the envelope itself. An envelope is essentially kind of like a Merkle tree-like hash, Merkle tree-like hash tree, so that there's a top-level hash, which is associated with the entire envelope, and changing any contents in the envelope except certain kinds of transformations, elision, encryption, and compression will actually leave markers of the actual original data in there. And so in this case, it's been lighted, which means the data itself is gone entirely. It's not encrypted, it's not compressed, it's just gone. But the hash is still left. So the hash tree still matches. And that's one of the superpowers of envelopes is you can actually transform envelopes to, for example, remove or encrypt certain data without invalidating signatures or other things like that that might be on the envelope.
All makes sense? So Bode, what do you see now the utility of envelope and why we're trying to do more with NFCs and you know, create APIs for all of this?
Yeah, yes, that's interesting. I was wondering the envelopes are encrypted. It was not clear to me.
So envelopes are
The,
not encrypted. They are by default, but you can encrypt parts of envelopes. So an envelope is essentially a tree of envelopes. So envelopes contain envelopes, essentially. And so almost every element you just saw, in fact, let me kind of summarize here.
can be combined or
Yeah, exactly. So envelopes can be nested with another envelopes. In fact, what you just saw, I want to go back to my terminal here for a second. Um, so this is an envelope, right? The actual subject of the envelope is an envelope. Each assertion, which is a predicate object, is an envelope. Each predicate is an envelope, and each object is an envelope. And so these things can be nested arbitrarily deep, and we have many examples of that. Now, and then envelopes themselves can be elided or compressed or encrypted using Cha-Cha Poly 2020 IETF 1305, Poly 1305. And eventually other encryption methods too, if we decide to support them, because envelope is designed to be extensible. In fact, the base specification of envelope only specifies elided, and then it's extensions that of that base specification that specify encryption and signatures and sharding and compression and things like that. So those are all kind of add-ons to envelopes. So minimum envelope does support elision. And that's very important for privacy, or for, in this case, we're using it to make something fit a QR code that wouldn't otherwise be pretty dense. But yeah, so you can essentially take an envelope, you can close it in another envelope, and then sign that. And then the entire contents of the other envelope is signed by the outer envelope. And so you could still elide something on the inner envelope, but because the hash key would remain the same and the signature would still verify. But if you actually change anything inside the envelope, then the signature would no longer verify.
Yeah, there's a lot of privacy oriented things in here. So, you know, let's say instead of doing seeds, we're basically, you know, putting, you know, that you've graduated from, you know, the Bitcoin command line course in there, you know, signed by Blockchain Commons. Well, you know, that potentially is privacy revealing. But since we provide it in an envelope, you can basically say, yeah, I can prove that I hold this key, and I can prove that I graduated from the, you know, the Learning Bitcoin from the command line course. But I don't have to give you my name. I don't have to give you any of the other information that might be in there. But even better, we, Blockchain Commons, could publish every single student in a single hash tree and basically give you a proof of inclusion in that hash tree that maybe is put on a Bitcoin op return, just a hash. And you basically could prove that you were, you know, a graduate of the Learning Bitcoin course amidst everybody else who possibly did so and yet be private.
Yeah, if you go to blockchaincommons.com, introduction, envelope intro, or just Google for Gordian envelope, you'll find this page, which basically talks about our motivations for envelopes, the kinds of things that envelopes can do, and you know how they support all these different features. And then the actual specification is an IETF draft called the Gordian envelope structured data format that we hope will become an RFC at some point. but it's been, and we do have an assigned CBOR tag for this, and then this basically covers the entire core specification. And then we have our research papers here. And this is if you go to our actual research repo, you'll see that we have the link to the Gordian Envelope internet draft. But we also have, for example, how would you do cryptography with envelopes? Well, these are our standards for cryptography that are reference implement. How would you do expressions? And expressions is how we do requests and responses, because expressions are basically function calls. And then these all dovetail with our UR specifications. For example, how do you represent output descriptors using URs and because everything is CBOR and everything inside an envelope is CBOR, that's how we get, for example, the output descriptors in our seeds, is we use our CBOR specification for this. How do you represent seeds themselves in Gordian envelopes? And so, all these things are extensions, in extension known values, extension, symmetric encryption, extension, compression. So, and then our reference implementations in both Swift and Rust implement all of these. So, and in fact, in Rust, if you don't need certain things, you can actually use compile time switches to actually turn off, for example, symmetric encryption, compression. If you're compiling for a more limited platform and you don't need those things or want those things, you can compile them right out.
Right. We do have TypeScript for the underlying DCBOR. And we're hoping to have, we have a variety, some of our different tools have multiple implementations in different languages, Python, etc. At this point, we do not have a Java card implementation of envelope. So that's like one of the projects we're trying to get funding for. Is, and again, you don't necessarily have to do all of envelope or DCBOR
right.
To do all these different types of functions. There are shortcuts that you can do in coding to be able to read and write these without necessarily having to understand all of the different possibilities of it.
Right. If you need to read or write specific envelopes, you don't need a whole envelope stack. If you need to know you need to read or write certain things in CBOR, you don't need a whole DCBOR stack, which does a lot of verification that everything is deterministic. But just realize that if you write, you have to write out a specific way, so other DCBOR decoders that decode it, when they check to make sure it's deterministic, they'll pass. But you can do that without using any CBOR stack at all, actually, if you're in a very limited environment. So while we're defining things in a very rigorous way that can be usable by a lot of different kinds of applications and with various kinds of security models, we're also being very careful to make sure that people who do embedded systems or limited systems can still ingest and write out these kinds of structures without having to have a huge amount of additional code.
Right. So what we need from you is, you mentioned, we would like to maybe put some public data into an NREF so that, when somebody first sees a SATO card, they know what to do. Well, we'd like to work with you on what that data would be. We'd like to see it encoded in some fashion as an envelope with the requests or other types of details that allow for a variety of different scenarios, so that when you tap it on any of the wallets that are used in the Gordian wallet community, the UX will know what the right thing is to do for this card. I mean, maybe this card has a display. So maybe this card doesn't have a display. Maybe this card points to a URL that is a Tor server that allows it to do more than you think it does. I don't know. There's lots of interesting things we can do with Quick Connect for NFCs that can be used for other things. And then obviously, we'd love to see the ability to back up a private key or restore a private key onto an NFC card. We have a library for that, but obviously the full implementation, needs to be done. And then obviously we'd love to see, the ability to very quickly go, hey, I need to create a descriptor, with a cosigner for my weird, Taproot, descriptor thing here, but I want this fifth Taproot leaf to be held by this NFC card. There's a whole process there that's, a pain in the butt to do manually. But if I basically have the ability to just put a special request onto the card, and then the card goes, oh, I know what you want. You need a pub key from me of this particular derivation. Sure, I'll give you that pub key. And then all those 25 steps that are in our in the scenario that Shannon and I wrote a couple of years ago are gone. You just tap, it just does the right thing. No NASCAR searching through 5 menus and sub menus and all that kind of stuff to get to the specific derivation that that Sparrow or some other wallet is requesting. They can just ask.
Yes, that's interesting. I still have to read about the whole process. It's very complete. You have think about every edge case, I think. So
Well, and certainly
but
but our community has been a huge help, obviously, because we're doing this for the community. So when you have questions, whatever, feel free to reach out to myself or Christopher directly, and we'll work with you to make sure that you feel comfortable. And any, we do miss things at times, and you'll see that, for example, we've gone through 3 iterations of how to represent output descriptors in CBOR, and the version 3 we're pretty much settled because we've gotten a lot of community feedback and advice on. And but these things take some time to get solid. Sometimes some things we're very solid on now, and that we expect will become eventually, hopefully, RFCs. So they'll be that solid, or BIPs. But that's part of what we need from the community is feedback. So and support. Yeah.
And I was wondering for the NFC tag. So when you use it with the Gordian Seed tool application on iOS, so you tap the card. It's just NFC storage, or
It's just
is it
using
more?
MREF. Yeah, it's just using the standard core NFC API in its kind of simplest mode, and it's also allows that when we've registered UR, so when UR is hit, it pulls up Gordian Seed Tool.
Yeah.
But but that's, yeah. So there's different ways that we're trying to use the most standard kind of simplest way of doing things. We're not doing things very, very sophisticated. We haven't worked with smart cards yet, but again, that's part of what the direction we want to move.
Yeah.
Okay.
I mean, we basically do now, we can put any UR onto a smart card if it'll fit. It will give errors. If not, it doesn't, I do not believe it currently supports lighting to fit on a card. We do.
No, it doesn't.
That.
It's either the whole thing or nothing right now.
Right. That is
Okay.
the next thing, so that if you put a large UR onto a small card, the next major release, one of our intended features is it will basically come back and say, hey, I can't, this failed because there wasn't room.
But now I know how big your card is.
I know how big your card is. I can exclude the notes. I can exclude the birthday. I can exclude everything but the seed if you really want me to.
Right.
And still be able to back up. And then obviously we're already using it in testing where a lot of these requests allow, we have a bunch of test cards that do the requests for various things. We'd like to add that. I don't think that, so the current version is 1.6, and again, it's in the App Store today, free today and tomorrow. But we aren't, at this point, until we know more and have some things from at least 2 organizations that want to do NFC APIs, direct APIs rather than NREF tags. We'll be adding that. That'll probably be post 1.7. I think one of our big things for 1.7 is just make the NREF stuff work better. And maybe support some more things. Like right now, Seed Tool is very focused towards seeds and doesn't really have a way to back up to shard only the keys without the seeds, which is useful in some scenarios. For instance, I'd like to back up my developer keys. Those are not. Yeah, I want to back up my SSH keys. I want to back up my Tor keys. All of those are not created from seeds. So how do I back those up? I'd also like to be able to, back up shares from other people. So I want to, in the same way right now, 2 months ago, Wolf demoed the Gordian Seal transport capability to do social key backup on a server. I'd like Gordian Seed Tool to be another place you could back up a share to. Those are all future things for Gordian Seed Tool, but
it's not possible to. Sorry.
Go ahead.
It's not yet possible to store a share on the Gordian Seed Tool. That's what you say.
So no, you can store a share, but you can't encrypt it in a transactional way, tofu, so that you limit the parties who can the share can be returned to. That's what the full share protocol does.
So right now you can hand shares to people. You can hand them digitally. You can hand them a printout, and they can't recover your seed, but a quorum of shares can. But what Christopher's talking about is the idea that you should be able to generate a seed and then say, select 5 servers out there in the community that are all public depositories of shares, and put 3 of them out there, and then put 1 in iCloud and hand me the 5th, and I'll keep that, and then I erase my seed. I don't even have it anymore. And then eventually we want to support things like Frost, where it'll gather a quorum for you and then create a signature without ever actually having the seed in one place. But for now, or the key in one place. But for now, we released last year a tool called Gordian Depository, which is a proof of concept server written in Rust that basically is backed by a MariaDB database that essentially you talk to it using envelopes as what's called Gordian Sealed Transport Protocol. And what this means is it doesn't even have to go over HTTPS or anything like that. It could go over air gaps. It could go over anything because the encryption is actually handled in the envelope and signatures as well. And it's also trust on first use. So here's a public server. I made this available as a public good. It's a depot server, a depository for people's shares. And so they send envelopes that say, please store this share. And here's my public key, and this is signing to my public key. And the depot server says, oh, okay, I haven't seen you before, but now you have an account. And I've stored your key. I've stored the share. And so then you do this with several ones, and they all trust you on first use. And then you get back a receipt, and then all you need is the receipt to get back those things, or you can, there's a way of rotating your key and things like that, so that you basically are distributing trust among a bunch of unrelated parties essentially who are all running these servers, and so they're not they're not colluding. So and that can be part of your thing. You can also friends, family, colleagues, whatever. Safe deposit boxes to socially back up your seed, but this could be handled entirely digitally. But there's the Gordian Sealed Transport Protocol doesn't reveal anything about what it's being asked to do in the envelope. All you see is this encrypted envelope. Once it's unencrypted, because it's encrypted to the server, once the server looks at it, it says, oh, this is a request to store a share. This is a request to retrieve a share. This is, you can't tell, a third party can't tell going back and forth what's actually being said at all. And it doesn't rely on HTTPS.
And a lot of this is a response to, ledgers and because there's some other parties that are now talking about doing social key recovery, but what the problem is you don't have a choice and you can't mix your recovery. So I'd be glad to use some and even pay for some social key recovery services. But I would never give a quorum of my keys. I'd probably do something like a 4 of 9. and put 3 of those on these social key recovery services, you know, 1 offline and maybe 2 with family members or whatever. But the point is I should be able to choose that. And this allows us to do things of that nature. And again, because envelopes can be wrapped in envelopes, you know, there's also some fairly interesting things. I could set it up such that if you recovered 3 of these, you know, you might get some information like my watch only descriptor. And when you get 5 of these, you now can you know, sign a transaction, but you don't get all of my transaction notes and history and such. And then, you know, if I have, you know, 7 of 9, you get every single thing back. You can totally restore every single thing that I've ever done.
So
Go ahead.
having talked to some users, it's not just about the key. It's also about like policy. So there's like a use case where it's like nobody wants to have custody of other people's funds because then you're at risk and you're a target. But if you for example give like if you set up a 2 of 3 thing where you give me, or me being like your cloud computer, you give me a key, you keep 1 key that you like keep in your safe and you never use it. So like for your daily usage, it's never used. And then you have a 3rd key and it's on an NFC card, which will sign the transaction. So now the policy is either me, like a trusted party, or your own sort of computer that's running out there somewhere. Like I saw this set up on AWS. So now it will only sign things in accordance to a policy that you trust, and then you have your NFC card to co-sign with. But you still have self-custody because you have all the keys, or you can like use your emergency key to spend everything not according to policy. I saw this. This is my idea. It was presented on Twitter by a guy like Rot13 Maxi Reindahl. He explained how he's using Nunchuck with, I think, a tap signer to achieve this kind of policy-based setup.
Yeah, so definitely this is, you know, in the design. You can see some hints about it. So if you go to smartcustody.com, you'll see the book, the 2019 book. But also you can sort of see here the most advanced of our scenarios pre some of these UR standards. So this is a very detailed scenario of for creating a multi-sig. It has 14 steps, you know, where some of the keys are stored in different places. And it's specifically carefully designed such that there is no single point of failure, no single point of compromise, which are slightly different. It basically worked. This particular one is oriented toward Gordian Seed Tool for one of them. Then the other is, this is Sparrow is the transaction coordinator, I think, in this example. And then we're using Foundation Devices for one of the other things. But the problem is when you actually go through this is very reliable, very solid, and addresses, you know, all kinds of alternative setups and whatever, is that it's still too complex. And so that's what part of the whole point of the Gordian protocols and such is, that, you know, you can now embed the descriptors. You can put policy information. Like one of the main things when Bode first came up, I was talking with him briefly about I'd really like to have an NFC card that says I will only be the last signer. So in other words, if you just give it a bare PSBT that you know, has the root XPub fingerprint that the card knows about, it'll go, well, no, I'm not going to sign that. You know, my policy is I must be the last signer. You know, or I at least have to have one other signature on there, or whatever the rules might be. So we really want to define these more firmly. In my own research on this, you know, it's a lot about where there can be trusted interfaces. One of the problems with NFC cards is most don't have a display, what we would call a trusted output, and most do not have a trusted input either. So that means the trusted output and input needs to be another device. And so we have to be careful that that device isn't compromised. So we want to be able to do things where that an NFC card that has no trusted input or output can do. And one of the simplest is, oh, don't give me a bare PSBT. It has to be signed by, because the thing partially signed Bitcoin transaction, which is what PSBT stands for, means I could have one, two, or all of the signatures already in there. So I would basically, my policy would be, oh, this is a 3 of 5. I recognize this descriptor because it was given to me when you initiated this NFC card, and my policy is I will only be the third signature of this 3 of 5. Are the other ones available?
And this is
Oh,
one of the nice
they
things
are.
about the Gordian envelope format is it's open. So as you saw from the examples I showed earlier, it's basically a subject and a set of assertions about that subject. And that subject could be a seed, it could be a key, it could be all kinds of things. And how we encode and interpret policies is a matter for future work. And we need the community's help to do that work, to understand what the policies are that people need to agree upon, the best ways to encode those, and the best ways for people to kind of execute those policies on devices. And so this is something that I think we're at the point of maturity now where we're ready to have those conversations, where we have working examples of adding metadata of various kinds, of making sure it's cryptographically secure and privacy respecting, and now working with the community to implement kind of a higher level policy structure that is kind of open and understood and transparent, but very secure, is something that is work we're ready to undertake. And we need interested parties such as you who are raising these concerns to work with us to help us come up with something that has the broadest applicability.
So there's a whole bunch of other resources when we were researching all of this. So this is the old SSKR, which only stores seeds, but we basically discuss a variety of the consequences of, like, how does a 4 of 9 work? I'm particularly enamored of the 2 of 3 of 2 of 3. It is somewhat by numbers a kind of 4 of 9, but the difference is that you want to have different social connections between these different groups. So, in this particular example, friends that are, say, maybe my colleagues, my professional friends or whatever, and the second social group is maybe family members. Why do you want to do that? Well, family members may collude against you. They may like your wife more than you or whatever, and you're concerned about that. By creating these social groups completely separate, now you require at least one friend and one family member to participate to do it, and you need a quorum of one or the other. And I also have the ability to have a self-sovereign choice in this. So there's a lot of different examples of how to think these and combine the scenarios. So this was a lot of useful, powerful work in how to do these, and we've very much have an adversarial analysis technique. I'm not going to show that, but let's see. Yes. Yeah, so here's the how do you do an analysis of a scenario? So we have this concept called the smart custody adversaries, and we have 2 or 3 pages of detail on all of these. So these are the things that any particular scenario you need to look through. Various kinds of key fragility, various kinds of convenience causes problems. I mean, that's actually a lot of why we're doing some of the Gordian stuff we do, is that, yeah, I can show you how to secure your keys self-sovereign in very secure, very proven ways, but it's inconvenient. Oh, it's going to take you 45 minutes of time to back up your $1 million of Bitcoin. I don't know why people make that choice, but that's the reality. So the adversary of convenience is, described here. And, we basically talk about the risks. We talk about the, how do you address those risks? And we try to, that's what a lot of the Gordian stuff is all about. So there's a lot of, things here where we're trying to help the community, not just the wallet developers, but also people like you, to be able to do better for to meet the security needs and be open and do so in a fashion that helps everybody. So that's what we do.
Bringing it a little bit back to NFC, I was thinking, like, there are some that do this already today, such as like the cold card. It does some, like, they have like a page up where they describe some like NFC 5 thing. But the question is, like, how does a wallet communicate with a signing device over NFC, and what would that standard look like? I also saw that Seed Signer had some Java card support, or like somebody was looking at adding USB Java card support to it. And then I was going to point out that there's probably a limitation to what the hardware can do. So what Java cards can do versus what like a computer or microcontroller can do to sign stuff over NFC. So how do you make it so that you can both make a Java card, which is sort of hard. I think there's like not a lot of people, or like in comparison to like people that would be able to develop stuff on a PC or on like a Raspberry Pi. There are probably a lot more that have that skill set than people that can make like Java card programs. So how do you
quite
get
a
them out?
restrictive environment.
How do you get
actually,
So
Java card is very easy to program. It's a subset of Java. And it's not very difficult to, let's say, the tool chain compiling and so on. It's not very difficult either.
Well, but you're constrained with both RAM as well as code storage, and
but you are constrained. Yes,
it is a very, for example, it doesn't even have a string type. So even so, it's a very limited subset of Java. Yeah, it doesn't have floating point values, which aren't necessary for a lot of things, but some things do take advantage of them. Things like that. And I think it has like a single integer type and a Boolean type, and that's almost it. So yeah, you have to build everything up out of those things, and that takes more code. So that's why I think I mean, at least I don't know what you can speak for himself, but that's what I mean when I think programming Java card is harder than, say, a Raspberry Pi, where you basically have a all Linux available to you.
So let me also, I kind of want to bring this, I'm going to be blunt. I'm very disappointed in CoinKite. I would have loved to have them be involved in this. They are not interested in open source, much less open development. We believe in blockchain commons that open source is not enough. And, there is more to it. And there's a whole article here about the limitations of open source and, what is required to do better than just open source. And CoinKite and Ledger have both basically said, no, we are keeping parts of our systems proprietary. We're not going to tell you. In fact, we won't even let you know and have any choice into what share services our new Ledger technique uses. And how that all works is not open source. And you'll find the same thing with CoinKite, that their protocols are not open. It'll only work with their cards. Their cards, not all of their, a lot of their source code is inspectable, but not open. But a lot of their source code is literally not available. And they'll basically say, oh, well, it's because it's under NDA by the card chip manufacturer. And that is true. A lot of Java cards do that, but there are also a lot of Java cards that are open. And that's what, Bodden here works for SatoChip, which is you know, a leader in doing interesting things in an open fashion on you know, sort of an open card. And I know I believe that the seed
Gatekeeper,
the
maybe?
yeah, there's several people that are using their code to make their NFC devices work. I know Foundation Devices is also, you know, obviously has a trusted element on their, you know, sort of phone-sized device, but they want to do multi-sig, so they're also supporting the concept of some more open standards and open development around how do we do integrate these types of things. And then we also hosted something called the Silicon Salon. Come on, am I locked up? No, there we go. We also hosted the Silicon Salon where we basically have discussions with various silicon vendors, because one of the problems of the Java cards at this particular point is they can't do the math for Bitcoin as safely as they can for other curves. And that means that there are various tricks where if somebody can get physical possession of a Java card, that you know, using freezing and other, you know, hacker tricks might be able to get your key out. Well, this whole series of events is all about, you know, software silicon designers that are looking on how to do this better. So there are going to be new cards and chips, et cetera, coming out in the next couple of years that will have more capability. And that sort of also leads me to another aspect of you know, future, you know, is the dependence on a single card for a key. There's this whole emerging capable thing of doing multi party computation. Rather than having things be done on a single key, you do something called distributed key generation. The advantage of that is that unlike SSKR, which is the state of the art that we currently support, you still have to recover everything onto a single machine, which then recreates the keys and does all the operations for you. But as these technologies mature, multi-party computation, now the quorum of keys of shares that you distributed can do things on your behalf if they need to, without having to any one party restore it all. So we've been, you know, doing some stuff there. There is a Bitcoin group at Square. I always get confused on which one's which. Spiral, etc. That whole Square, you know, consortium along with Blockstream that are working on.
Speaking of which,
yeah, they're
Block,
working on.
uh,
Yeah, that's it.
so they also have like a hardware wallet that does NFC, but they've been very closed about, or not necessarily closed, but they haven't talked a lot about how the NFC thing works. So that would be like another interesting thing in terms of like, yeah.
So we need pressure from people like you to go to these guys and say, hey, you know, there is open development happening on this. You know, there is open source code, open architecture. I mean, all these aspects of things. I mean, we consider Zero is, you know, open source, but it needs to be inspectable. It needs to be observable, reproducible. We're working on all these. It has to be testable. We have to share our roadmaps. We have to, you know, work on our specs together. You know, we have a bunch of standards where, you know, we basically say it's not doesn't get a star until at least 2 companies have actually implemented and committed to it. You know, we are committed to no vendor lock-in and no single points of failure. And then, you know, we're trying to deal with other kinds of lock-in, patents, IP regimes, et cetera, by also cooperating with international standards organizations. So, you know, DC-BOR has already been submitted to ITF and looks like it's on RFC track. and Envelope looks like it has an opportunity to be so as well. And then all of this kind of fits in with Open Salon. But we really do need people like you to go back to Block and to CoinKite and things of that nature and say, hey, reconsider your non-open source or non-open development practices. And there is a community that is trying to work on these things together and be smart and do it right.
Yeah, I also think that they won't gain the necessary traction of like wallet adoption without and I also think they have like a competitive advantage, as you said, because you have like this sleek looking device, or you have like a nice printed card, and it has like the newest, latest like tamper protection in it and whatnot. But if you at the same time also have like a $5 card that's just like a blank card that you can get on Alibaba, and it'll work in the same way, though it might not be, you know, as secure, and you might not be supporting, and you might not like get the artwork and stuff. Then you get like broader adaption, and you could really make this work. It'd be awesome if like wallets could communicate over NFC instead of using QR codes, and that you could like opt into that if you were doing like multi-sig, or like what the future holds in terms of like what you were talking about, like Frost and stuff.
Yep, we definitely want to, you know, this is so Foundation Devices is one of the sponsors of Blockchain Commons. And they're committed to working in this different direction. We have other sponsors. We're a not-for-profit, so, you know, we depend on people like these to be able to do what we do here. But we need more. I mean, and especially this year has been, you know, kind of a crypto winter for, you know, funding of these types of things. So, you know, we really need the blocks, you know, the bigger companies to basically say, yeah, you know, we want to support open standards on these types of things in the same way Foundation Devices has. And they've made a very, very firm commitment. If you go to their blog posts and things of that nature, you know, it's you know, their secret master plan or whatever, you know, they're very committed to freedom technology,
Right.
as we are. So you know, so we need everybody's help on this at a variety of different levels. Let me actually jump ahead to so that's my information. I'm at Christopher A on most services, although X and is probably the one I respond fastest to. Still haven't quite gotten quorum on Blue, one of the new services. Obviously, blockchaincommons.com is our main website. We do these meetings monthly. And our next month meeting, we're going to be diving deeper into Frost and Taproot. So if those are things of interest to you, there's going to be a particular focus there. And then I'm hoping that, you know, maybe within the next couple of months, the various NFC developers that have gathered together in our kind of subgroup on NFC stuff have some proposals for some initial improvements and to our APIs and such. So you know, keep an eye on it there. Bob, do you have any last questions or comments?
I would be also interested to attend the next meetup about Frost and Taproot. We are also working on Taproot support on Satochip. So it's in beta. No, it works. The code well, is open, and we would like to work with like a university to have a kind of security audit and evaluate the security of the implementation. We now improve some aspects about it. For example, side channel attacks. But so it's also very interesting. And yes, we have a tool called an application, an NFC card called Seed Keeper, which is also yes, it's the third one. which is used to store and backup seeds on a smart card. So it's a bit like Gordian tool, but on a smart card. It's much more simpler. There's not as much functionalities as the Gordian Seed tool because, as you say, the smart cards are very constrained. So and then again, you don't have a screen. So you have to somehow interact with another device to import, export seed or generate seed and so on. But
Well,
yeah.
we'd love for you to, start accepting these Gordian sealed requests, and so that anybody can create a front end for your seed keeper to retrieve the seeds and approve things, etc.
Mhm.
That'd be a great thing. And then you could put one of the challenges with even with seed keeper is how to seed keeper back up that key. You could basically have seed keeper itself be able to back up to other NFC cards.
Yes,
If you
that's actually that's currently already supported. So you can have a seed on a seed keeper and then back it up on multiple seed keeper, for example. We don't have the SS carrier functionality yet, so that's something we are also looking. So to have the possibility to, for example, store a seed on the seed keeper and export share on whatever you want, other seed keeper or on a, on a wallet, for example, and recombine them also on a seed keeper. So
so
yeah.
Also, again, we are a not-for-profit. Most of our money comes in through this GitHub channel. So, I would encourage if become a personal benefactor. If you like what we're doing and these meetings we're doing and the successes we've had with over a dozen wallet companies doing the air gap QR codes now and such, become a personal benefactor at $20 a month, or have your company become $100 a month developer, or we have these higher levels of support where uh, you're a sustaining sponsor like Foundation Devices is, or we can actually help. You want your smart custody things to be reviewed for your particular scenarios. At these sustaining research sponsor levels and sustaining partner levels, we can personally help you with your projects. I mean, just to give you an example, actually, I think it's under smart. Shannon, where is the thing we did for Foundation Devices? The review of their. Oh, you're muted.
Yeah, we got the house next door again. Go to the smart custody main page.
Oh,
And I think if you scroll down a little bit, everything's linked in there. Case studies, there you go.
yeah. So we did a deep analysis of Passport version 1.08, looked through all their different things, the different levels of support they had for stuff. This was not a code review, but it was, again, looking at, sort of the adversarial analysis and openness and other requirements, for such. And because of that, they made some improvements on their work. And then, we obviously, as Bob was pointing out, there are real issues of getting security reviews on this type of stuff. They're expensive. So one of the things that we did was, had our community commission security review for one of our critical libraries. It's not JCSSKR. Just trying to find the library that has it. Wolf, what's the library that has the? Oh, it's BC Commons.
Um,
Here it is. So we actually had a formal security review done, commissioned by our partners, and all of the information about that. So I mean, that's another problem right now, is that these reviews can be anywhere from 20 to $100,000, or even $500,000 for a big detailed project. That's a lot of money for a small organization. But if we're all sharing important code, we can split the costs and get these important security reviews done of the mission critical code together. So that's another benefit of being part of this commons that's going on here.
Yep.
So anyhow, back to here. I'm Christopher A. at Blockchain Commons, Christopher A. at Life with Alacrity, etc. You can direct message me on a variety of places. And of course, the Blockchain Commons website has lots and lots of detailed blog posts, architecture discussions, etc. So I hope these will all be useful to you.
Sure.
Okay, well, we'll call this a close for now. See you in a month where we'll be talking more about Frost, and everybody have a good month.
Thank you. Thank you for the call and the discussion. Very interesting. And hopefully see you in a month.
Yeah.
Yeah. Thanks for hosting.
Thank you for coming.
Okay. Goodbye.
Goodbye.